Okay, welcome back. My name is Karr. We're back at the Center for Innovation here in Laurel County, and today I'm tasked with giving a skill-based lesson plan presentation. Now, this presentation is operating under the assumption that your students have already been trained for safety, PPE, have had some rudimentary hand tool training, and that they're fairly familiar with how to run and install things like non-metallic sheath cable, Romex cable. For this presentation, what I'm going to do is I'm going to go ahead as if students were present. You can see by the lab behind me that there are no students in here right now. My goal for this presentation is to be able to keep this video and to show future students an example of the skills that I want them to build, and to begin to create a library of videos like this that I can use to demonstrate further skills to my students they can reference at any time. All right, for today's presentation, the materials that I've gathered, I've got a pair of cable strippers, Klein, very standard for the trade. I've got a Phillips head screwdriver, insulated. I've got a very simple single pole, single throw switch that we're going to be installing. And of course, I've got some 14-2 non-metallic sheath cable. Now here at the school, we utilize 14-2 primarily because it is cheaper and the students will be going through quite a bit of it, and the 3-conductor cable as well. So without further ado, we'll get into the lesson. Okay, folks, so now time for the main event. Gather around, please watch, okay? Pay attention. Now, first things first. What I've got here is a piece of what's commonly called Romex cable. It's non-metallic sheathed NMS cable. This cable sees a lot of use in residential, commercial, and even some industrial applications. One of the most common types of cable we used around the world, okay? Now, this cable has some very specific things that we need to do before it's ready to be attached to a device and before we can safely say that the device has been terminated, okay? Now, right here, attached to the stud in our wall, we've got a double gang box that is installed to the correct depth for our drywall. Okay, we can tell by the indicators here on the side of our box, which runs directly into the stud. Remember, our cable, if at all possible, should try to run up the center of the stud and into the bottom of the box in the closest possible clamp, which is what we have here in the back of the box. We can see this row of clamps along the back, all right? And those are there simply to hold the cable in place and prevent it from sliding back, as we'll see in just a second. Now, I'm going to feed my cable in with the sheath on, and you'll notice it's pretty stiff coming in there, okay? We're going to fish it out. We feed it up from the bottom, which is going to be our home run, which is going back to our panel box, and code calls for 6 inches of cable to be exposed from the box. Now, it can be hard to try to go every single device, every single box installation, and start measuring 6 inches of cable. So a good rule of thumb that I have is I like to give it the thumbs up method, okay? What I like to do is grab the end of the cable, extend my thumb inward, and if I can touch the top of the clamp where the cable feeds in, that's going to approximately be 6 inches, okay? Not 100% precise, but a fair indicator, all right? That and just experience. Like we talked about before, experience is one of the best learning tools that we have. So what I'm going to do, now that my 6 inches of cable is hanging out of the box, I'm going to take my cable strippers and I'm going to open those up. Remember, the lock is on the side. You need to be careful with these, okay? They are a cutting tool, they're a scoring tool, and they have teeth. They can bite us, all right? Leave some rather nasty little wounds. Now, the special thing about these on the side, which will be hard to see on the video, but which is apparent when you're holding them, is that they're marked for 14-2 and 12-2, two of the most common cables that we use in a home. Now, these teeth are designed specifically to fit over the cable. So we pick our appropriate size, the 14.2. We get as close to the back of the cable as we possibly can. And we want to watch out and not nick the wires, okay? All we're trying to do is score that plastic, that outer sheath, and then we're going to remove it. So you can see our clamp still has our cable. The cable has been removed of its sheath, roughly 6 inches of sheath. We discard that. And now we've got 3 conductors, 3 separate wires. We have a white, a bare, and a black, as well as this paper sheet that came on the ground, which we can just go ahead and remove. Now, the next part of our project, the next part of our lesson, is I'm going to show you how to make hooks for terminations. Now, normally, we'd start with the grounds, move to our neutrals, the white wire, and we'd finish the installation with our black wires, these hot wires. Today, since we're not running another piece of cable to continue on with, we just have the one in the box, I'm going to go ahead and strip this piece of black cable, making sure that I'm on the right size tooth, because down here we have a place that will specifically be used to strip off this size conductor, okay, to take the outer plastic off this, the insulation. So we're going to size it up. It says 14 solid right here. We're going to clamp and remove that outer sheath. Now, I've heard a lot of different things from a 1/2 inch up to 3/4 for some guys. That's really not required. About a 1/2 inch is going to be plenty sufficient for what we need. And a lot of devices even have marks on the back of them to show depth, to show the appropriate amount of wire to be stripped. Now, once we have our wire exposed, as we do here, we can grab the very tip of the wire using the flat part, the pinching part of our cable strippers, needle nose pliers, and we're going to roll it, okay? When we're done, we've got this very lovely looking little hook here. And that's what's going to be terminated on our device. This is what's going to hold our wire to our device. Now I'm going to show you one more time using the ground, okay? Just to make sure that we see this, we're going to pinch using the grabbing part of the tool and just roll, all right? You want to keep that pretty tight. Not so tight that we can't fit it around the screws, we'll see in just a second, but a pretty neat little loop, all right? Now, we're going to take our handy dandy single pole, single throw switch like we'd see in most installations. It's got 2 copper colored terminals here, which will be our incoming and outgoing hots, okay? And it's got 1 green screw that's meant for our ground, all right? Green for ground, copper is typically going to be hot. So first things first, I want to make sure that my switch is oriented so that it can be read, right? Very important. We want to make sure the switch stays the correct direction. And we'll make sure our terminals are backed far enough out that our hook will go around them. We want our hook to run with the terminal. So we're going to turn our hook around, and then we're going to slide it on to our terminal. And I know it's going to be hard to see, but look. Here we go. You can see my hook is coming this direction, the same way we're going to tighten, okay? All right, so here we have our 2 little hooks, and we're going to attach these hooks to our handy dandy single pole, single throw switch here. Very standard, very common. Now, first things first, we've got 2 copper terminals. These are for hot wires, okay? 1 coming in, 1 going up to whatever device we're trying to control. And we've got a green screw that's meant for our ground wire, okay? So we're going to install 2 wires onto this device. We're going to terminate them, which just means to connect. Now, always be sure that your device is facing so that it can be read. We have on and off. I'm going to first take my ground wire. Here's our hook, and you'll notice our screw will tighten to the right, clockwise. So we're going to take our wire and hook it so that we can tighten clockwise and secure the device, the wire to the device. Take our Phillips, snug it. And the intent is, since we're going clockwise and the hook runs with the motion, it actually will pinch the hook closed as we finish the termination. So if we look right here on the side, We went with it. There's no wire sticking out. It doesn't look odd. And as we tightened it up, it actually pinched the wires together on the back there, which hopefully you can see a little bit of. Now, since my ground is hooked up and we don't need a neutral for a single pole, single throw switch, I'm gonna go ahead and I'm gonna connect my hot wire as well. Now notice our terminal will tighten this way. We're gonna take our wire, our hot wire, and we're gonna slide it over the back of the terminal and around the hook. Now I'm sorry for the difficulty here. It's an odd angle for me because I'm trying to show you. But you'll notice we went with the terminal and we're gonna tighten it down. And as we tighten, what we're gonna see is it's actually pulling that wire. It's actually trying to snug it and tighten it up, so that when we're done, we don't destroy the screw, we don't destroy the terminal, and our wire is very snugly held, okay? That's all there is to it. It's a relatively simple skill, but it's an essential skill that every electrician, technician, and maintenance man or woman needs to know. I really appreciate you guys taking the time to listen to me. I appreciate you paying attention, and we'll see you on the next one, okay? Bye-bye.